the topic biofertilizer and soil management via microbial and bioremediation technique. And the name of the expert is Dr. V. Nirmal Kannan. Introduction about the chief guest. We are truly privileged to welcome Dr. V. Nirmal Kannan, an accomplished academic leader, researcher, and administrator, currently serving as the principal of Mohammed Sadek Engineering College, Kilakarai. With over 20 years of rich teaching and administrative experience, Dr. Nirmal Kannan has held leadership roles in several reputed institutions, including VSB Engineering College, James College of Engineering, Sri Venkateswara College of Engineering, Magna College of Engineering, SRM University, and others, etc. He earned his PhD in Mechanical Engineering from Annamalai University after securing gold medal in ME CAD from SVCE, Anna University, and holds MBA in Operation and United Business Institute, Belgium. As a principal, his achievements are exemplary. He has successfully obtained autonomous status, NBA accreditation, and NEC A+ recognition for institution under his leadership. He has also achieved 100% admission expanded academic programs and significantly boosted student placement with the leading multinational companies. Dr. Nirmal Kannan has contributed extensively to research, securing more than 1.2 crores in funded projects, published 32 research papers, 2 books, and 6 patents, and among this, 1 is granted and 1 copyright. He is also a certified lead auditor for green energy and environment audits, actively promoted sustainability in education. He audited reputed institutions like ACTEC Karaikudi, Gandhigram Rural Institute, Dindigul. His excellence has been recognized with several awards, including Best Principal Award, Best Teacher Award, Research Excellence Award, and AICT Jal Shakti Abhiyan Award. We are honored to welcome Dr. V. Nirmal Kannan, an inspiring academician and a visionary administrator, as our chief guest today. Welcome you, sir.
Thank you, Muthuvel. So let me share my slide. Muthuvel, whether my slide is visible?
It's visible, sir. Good to go, sir.
Okay, thank you. So first of all, I would like to thank Dr. Vadivel and Professor Muthuvel for organizing this ATAL online 6-day FDP on bioremediation and green technologies for waste management and soil health in the agri-food sector. So today I'm going to discuss about soil management via microbial and bioremediation techniques. So in a FDP, giving lecture for the last session is very tough job. So they have given the tough task to me. Anyway, so I thank all the participants, those who joined in this FDP. So now we are going to see about soil management via microbial and bioremediation techniques. So what is soil management? So there are many definitions for soil management, but the main thing is that it is the application of operations and practices and treatments to protect soil and enhance its performance. So the main concepts include soil conservation, soil amendment, and optimal soil health. So in agriculture, some amount of soil management is needed both in non-organic and organic types to prevent agricultural land from becoming less productive over decades. But organic farming in particular emphasizes more on optimal soil management because it uses soil health as the exclusive or nearly exclusive source of its fertilization and pest control. So the first question is, what are the goals of a good soil management program? So there are mainly 2 goals. So high crop productivity and quality, and high environmental quality and limited human risk. So if you see high crop productivity and quality. So if the soil management, if you're having a good soil management, so can get good yields, can make money, and farms stay in business. And if the soil management is excellent, high environmental quality is improved, and limited human risks are there. So mainly no chemicals that are bad for animals or people, prevent runoff and soil erosion, recycle nutrients through the system. And the main components of good soil management are three. The three main components are physical soil health, and soil nutrients and pH are balanced. It should be balanced. Pests and diseases are controlled. So these are the three main components. So whatever techniques if you are taking, you should concentrate on these three components. So mainly you should know about the types of microorganisms in soil. Then only you should go deep about microbes and bioremediation techniques. So how we are doing that. So living organisms, both plants and animals, constitute an important component of soil. So cultivated soil has relatively more population of microorganisms than the fallow land, and the soils rich in organic matter contain much more population than sandy and eroded soil. The microbes in the soil are important to us in maintaining soil fertility, cycling of nutrient elements in the biosphere, and sources of industrial products such as enzymes, antibiotics, vitamins, hormones, and organic acids. So the soil organisms are broadly classified into two groups. So one is soil flora and soil fauna. So soil flora consists of micro and macro flora. That is, micro is nothing but bacteria, fungi, molds, yeasts, mushrooms, acetonomites, and streptomites. And macro flora, it's nothing but roots of higher plants. And soil fauna again divided into microfauna and macrofauna. So microfauna consists of protozoa and nematodes. Macrofauna is earthworms, moles, ants, and others. So straight away we go to bioremediation, so which helps largely in soil management. So first of all, bioremediate means the use of biological organisms to solve an environmental problem such as contaminated soil or water. So it is known as it's a waste management technique that involves the use of organisms to remove pollutants from contaminated site. So the main thing is that the microorganisms used to perform the function of bioremediations are known as bioremediators. So we have many bioremediators. We have many techniques also. So it is one of the most economic remedial techniques present available for treating most organic fuel-based contaminants such as coal tars and liquids, petroleum, and other carcinogenic hydrocarbons such as benzene and naphthalene, and some inorganics. So bioremediation is a triple corner process. So if you see the diagram, you can understand. So in the triple corner process, you have pollutants, organisms, and environment. Pollutants, you have inorganic and organic. So again, organic is divided into solid, waste, solid, liquid, and gas. So if you consider environment, soil, water, and air environments, and organisms, microorganisms, plants, and enzymes. So how it works, how the process of converting the waste soil into good one, and how bioremediation the process is working. So waste material is examined first, and certain bacteria are isolated based on their efficacy at digesting and converting the waste. That is the first process. And indigenous or local bacteria is to be used according to the environment. The bacteria then go through several steps of cultures and process for performing testing. That is performance testing. The suitable bacteria are placed back in the waste environment such that they grow, thrive, and in the process digest and convert the waste into carbon dioxide and water. The right temperature nutrients, and food also must be present. Conditions may be improved by adding amendments. So these are the process how the bioremediation is working. And essential factors for microbial bioremediation. So factors and the say conditions are given in the slide. So microbial population, the desired condition is suitable kinds of organisms that can biodegrade all the contaminants. So oxygen enough to support aerobic biodegradation. So about 2% of oxygen in the gas phase or 0.4 milligram per liter in the soil water. And water, soil moisture should be from 50 to 70% of the water holding capacity of the soil. Nutrients, nitrogen, phosphorus, sulfur, and other nutrients to support good microbial growth. Temperature, approximately temperatures for microbial growth is 0 to 40 degrees Celsius. pH value is 6.5 to 7.5. So then comes the types of bioremediation, which is used to strengthen the soil management. So two types we have, in situ bioremediation, cleaning up of contamination at the site where it occurred. Ex situ bioremediation, cleaning up of contamination out of site. So first, in situ bioremediation. So it also contains two main types: intrinsic bioremediation and accelerated bioremediation. Intrinsic bioremediation uses microorganisms already present in the environment to biodegrade harmful contaminant. In accelerated bioremediation, either substrate or nutrients are added to the environment to help break down the toxic spill by making the microorganisms grow more rapidly. Methods involved in situ bioremediation, there are many methods. The first one is biosparking. Biosparking involves the injection of air under pressure below the water table, so underground water, to increase groundwater oxygen concentration and enhance the rate of biological degradation of contaminants by naturally occurring bacteria. So you can see this figure, you can understand what it happens. The air is injected under the pressure with which the groundwater under the water table, microbial degradation, the process is going on. So next one is biostimulation. Involves supplying of oxygen and nutrients by circulating aqueous solutions through contaminated soils to stimulate naturally occurring bacteria to degrade organic contaminants. Next one is bioventing. Bioventing is the most common in situ treatment and involves supplying air and nutrients through wells to contaminated soil to stimulate the indigenous bacteria. Bioaugmentation is another bioremediation method which frequently involves the addition of microorganisms, indigenous or exogenous, to the contaminated sites. Next comes the ex situ bioremediation. Ex situ bioremediation is only used when necessary because it's expensive and damaging to the area since the contaminated land is physically removed. Land forming is a simple technique in which contaminated soil is excavated and spread over a prepared bed and periodically until pollutants are degraded. All you know that composting process. So composting is a technique that involves combining contaminated soil with non-hazardous organic compounds such as agricultural waste. The presence of these organic materials supports the development of a rich microbial population and elevated temperature characteristics of composting. Bioremediation of heavy metals. Heavy metals cannot be destroyed by microbes. That is the main thing. But can be transformed from one oxidation or organic state to another. So this may result in either of the following result: more water soluble, inherently less toxic, less water soluble, or volatilized. Bioleaching. Some microorganisms can produce metal leaching organic acids. Example, Thiobacillus are capable of producing sulfuric acid, which can form metal chelates. Many microorganisms produce siderophores, ion complexing molecules, some of which have heavy affinity for heavy metals and form metal chelates. Example, Pseudomonas for copper and zinc. Biopsin, metabolism independent absorption of heavy metals to biomass, can use low cost waste biomass sources such as spent brewery yeast. Some bacteria, example alkaligenous eutrophius, can also absorb metals like cadmium and zinc. Bioimmobilization, immobilize metals by precipitation. Microbes precipitate heavy metals by changing their valence. The process is called enzyme catalyzed transformation.
ఈ 2 months లో
Also include formation of
natural
insoluble
content
metal
more
sulfates and sulfates.
technically.
Bioremediation of pesticides. Pesticides are persistent organic pollutants. Several methods are employed in bioremediation of pesticides. So, degradation by microbes. Some pesticides are readily degraded by microbes. They use the organic chemicals in pesticides for growth and reproduction. And biotransformation, oxidation or reduction, hydrolysis, etc. of pesticide by enzymes present in different bacteria, fungi, plants can transmit it into less or non-toxic compounds. Next one, leaching. Since many of the pesticides can be solubilized or soluble, they can be removed via leaching. This slide shows the details of phytoaccumulation and phytoextraction, bioremediation of oil spills. Crop plants like brinjal, spinach, radish, rice can bioaccumulate pesticides like DDT and benzyl hexachloride. Bioremediation of oil spills. So oil spills threaten public health and safety by contaminating drinking water, causing fire and explosion hazards, diminishing air and water quality, wasting non-renewable resources. So this slide shows the methods involved in bioremediation of oil spills particularly. So seeding with naturally occurring microbes. So bioremediation of oil spills is an important topic in soil management, where seeding with natural occurring microbes have many microbial genera like Mocaria, Bacillus, Streptomyces, Coriforms, and 70 others are known to contain species that can degrade petroleum components. So environmental modifications, factors like oxygen supply, nutrient concentration, temperature, pH, pressure, salinity, etc. of the contaminated area is modified in favor of the acidity of degrading microbes. Bioremediation of plastics. So degradation using endophytes. Several plastics contain the same chemical bond that are found in natural plant polymers. Endophytes, organisms that symbiotically grows inside plant, can degrade these similar bonds in plastics. Example, endophytic fungus Pascloteophis microscope can degrade plastic polyester polyurethane. So next slide shows the degradation by microbes. Many microbes can degrade plastics and use it as energy or carbon source. So these are all the techniques of bioremediation, which uses to strengthen the soil management. And since this is a last session, so I have limited details for you. I think it is a summary of all soil management via microbes and bioremediation techniques. So thank you one and all for the opportunity. And since this is the last session, being principal of this college, Mohammed Sadek Engineering College, so I extend my thanks to all the participants, those who spend all these 6 days and gained knowledge about bioremediation and mainly all topics in agri-food sector. And congratulations to the organizers, Dr. Mithwil Vadivel, and congratulations to all the experts, those who have given excellent presentations. And this FDP on bioremediation and green technology for waste management and soil health in agri-food sector, conducted by Mohammed Sadek Engineering College, was a wonderful event. So we are conducting FDP. I think in every semester we got one FDP, and we are already chemical department conducted offline FDP, and this is online. So since we are interested to conduct FDP in various topics, so it will also continue. So your support is needed. So thank you very much. Muthuvel, over to you.
Thank you very much, sir. On behalf of management, principal, vice principal, dean, academic, I thank all the participants for participated in this ATAL FTP. Sir, you can unshare your screen, sir. I have to take the photo screenshot. So all the participants are requested to switch on your video. I will take a screenshot for the last session. Please switch on your video. And request all the participants to share a feedback in 1 minute video and send it to our mail already posted in the group or in the WhatsApp group. Thank you very much. Thank you very much for all the participants to participated in the ATAL FTP. And my special thanks to our beloved principal who continuously encouraged us to organize this kind of event. Thank you, sir.
Thank you.
Thank you all. And your assessment test will start at 8 o'clock in the evening, and it will end in the tomorrow 8 p.m. So all are asked to attend the assessment without fail. In your login, ATAL login, attend the assessment at 8 p.m. Thank you.